Hi, how's it going? Welcome to Code with Z. Today's question is LeetCode number 22, generate parentheses. Now I'll explain and visualize everything in the coming slides, but for the sake of reading the question itself, let's see what the question is actually asking us for. In this question, we're basically given m pairs of parentheses. This is gonna be a number and it's gonna represent the pairs of parentheses that we can have, and we gotta generate a bunch of parentheses. As you can see here, our n is 3, and we've generated these parentheses, and they're all valid parentheses. But how do we go from this to here? I'm glad you asked. Let's solve this together. So first, I'll explain the structure of our algorithm, and then I'll visualize every step. These slides took me ages to build, but I hope it provides you with value. And I won't finish this video until I make sure you fully understand how to solve this problem once and for all. This n is the only thing that we were given, and we can actually think about it as the number of open and closed parentheses that we can play with. So because our n is 3 and it's representing the pairs of parentheses that we can have, we can actually play with 3 open parentheses and 3 closed parentheses. Alrighty, so we know we can only have an open parenthesis and a closed parenthesis. We only have these two choices, right? And we can add a closed parenthesis to an open one, and this is gonna be a valid result. But if we add an open parenthesis to a closed one, it's gonna be an invalid result. So while we have these to play with, we gotta make sure that we only add a closed parenthesis when we already have an open one, because if we add the closed parenthesis first, there's nothing we can do to actually fix this. So let's write that down. We're gonna say only add closed parenthesis if we already have an open parenthesis. But how many open parentheses can we actually add? So we know we can only have 3 open parentheses because our n is 3. So let's write that down. We're gonna say if the number of open parentheses is less than n, add an open parenthesis. So we can only add an open parenthesis when this is true. And as long as we have less open parentheses than our n, this is gonna be true. And believe it or not, this is everything we need because we can easily convert this into code, and we can say if open count, meaning if the number of open parentheses that we have is less than n, we can add an open parenthesis. And then below it we say if close count, meaning if the number of close parentheses is less than open parentheses, we can only then add a close parentheses. I'll take this and put it here, and this is our n. And now let's visualize everything. So these two lines are basically our algorithm, and this is what we start with. It's gonna be an empty string. So in our algorithm, we're gonna ask ourselves, is the amount of open parentheses that we have inside of this string less than n? Well, n is 3, and the amount of open parentheses that we have now is 0. So 0 is less than 3, and we can easily add an open parentheses to this. And then we're gonna ask ourselves, is the amount of closed parentheses that we have less than our open parentheses? Well, we don't have any open parentheses in our string yet, so we can't actually add anything, and we're gonna ignore this. So let's do that. We added our open parentheses, but we can't add any closed parentheses. And if you remember, if we add our closed parentheses first, it's gonna make this invalid, and this is why we actually have this condition here. So we can only have this now. Now we have this, and we're gonna repeat this. We're gonna ask ourselves, is the amount of open parentheses that we have, which is 1, less than n, which is 3? It is. Alright, we can add an open parenthesis. And here we're gonna ask ourselves, is the amount of closed parentheses, which is 0, less than the amount of open parentheses that we have, which is 1? It is. So we can also add a closed parenthesis. So let's do that. We're gonna add our open one, and we're gonna add our closed one. And as you can see, we have a backtracking approach here, and we're looking for every solution. So now again, we're gonna ask ourselves, is the amount of open count less than n? Well, open count is 2. We're checking it for this one. And n is 3, so we can add another open parenthesis. And then we're gonna ask again, is the amount of close count, which is 0, because we're checking it for this one, less than open count, which is 2? It is, so we can also add a close count. So let's do that. We've added our open parentheses, and we can also add a closed one. Now we're gonna check it for this one, and we gotta ask ourselves, is open count, which is 1, because we only have one open parenthesis here, less than 3? It is, so we can add an open parenthesis. And is close count less than open count? Well, close count is 1 and open count is 1, so no, so we can't have anything here. So the only thing that we're gonna do for this one is adding an open parenthesis. So let's do that. As you can see, it's added here. Now we gotta repeat the same thing for this one. We're gonna be like, is open count less than n? Well, you see we have 3 open parentheses here, and our n is 3. So no, this is actually not true. So we're not gonna actually get inside of this if statement. And then we're gonna check, is close count less than open count? Well, close count is 0 and open count is 3. So we can actually add a close parenthesis. So let's do that. Then we're gonna check it for this one. We're gonna say, is open count less than n? It is, because we only have 2 open parentheses, and our n is 3, so we can add another open parenthesis. And then we're going to check if close count is less than open count. It is, because open count is 2 and close count is 1. So we can add another close parenthesis. So let's do that. As you can see, this is for the first one, we add an open parenthesis. And this is for the second one, we added a closed one. Then we're going to repeat the same thing for this one. We're going to be like, is open count less than n? Well, open is 2 and n is 3. So we can add another open. And is close count less than open? Well, open is 2 and close is 1. So we can actually add another closed. So let's do that. We're going to add another open parenthesis. And we're going to also add another close parenthesis. Now we have these and we're going to apply our algorithm to this one first. We're going to check if open count is less than n. It isn't, because we have 3 open parentheses and our n is 3. So we're going to ignore this line. And then we're going to check if close count is less than open count. Well, open count is 3 and close count is 1. So you can actually add another close parenthesis to this one. So let's do that. Then we're going to apply it to this one. Open count is not less than n, because we have 3 open parentheses here. So we're going to ignore this line. And close count is actually 1 and open count is 3. So we can actually add another close parenthesis to this one. So let's do that. And now we're going to apply it to this one. We have 2 open ones and 2 closed ones. And as you can see, open count, because it's 2 and our n is 3, we can add another open one to this one here, but we can't add any other closed parentheses because our open count is 2 and our closed count is also 2 here. So we're going to only have this here. And as you can see, we've only added 1 open parenthesis here. Then we're going to apply it to this one. We have 3 opens and 1 closed. So this one is going to get ignored because we have 3 opens, and we're going to execute this line because we only have 1 closed and 3 opens. So let's add a close parenthesis here. And then finally, we're going to apply it to this one. We have 2 opens and 2 closed. And we can only add 1 open because our open is 2 and it's less than 3. So we can actually add 1. So let's do that. We've only added an open. And then we have this, and we're going to apply this algorithm to this one here. We have 3 opens and 2 closed. And we can only execute this line. So we're going to add another closed. And this is actually going to be one of our results because we can only have 3 opens and 3 closed. And as you can see, we've used all of them. And for this one, when we apply this algorithm to this one here, we have 3 opens and 2 closed. So you can only execute this line here. So we're going to add another closed because we only have 2 closed here. As you can see, 1 and 2. So let's add another closed, and this is going to give us an answer. And then for this line as well, we have 3 opens and 2 closed. So you can actually add 1 other closed to our answer. So let's do that. And this is going to be another answer. And when we apply our algorithm to this string here, we can see that we have 3 opens and 2 closed. So we can only add another closed like so. And as you can see here, we have 3 opens and 2 closed again. So we can only add another closed. And this is going to be our answer. But how are we going to return these? Well, you see the amount of open parentheses and closed parentheses are all equal to 3. As you can see, 3 opens, 3 closed, 3 opens, 3 closed. And same thing for all of these. So we can actually add another line here and say if open count is equal to n and close count is equal to n, add all of these to our result and return it. And this is it. Now let's code this in the simplest way possible. Alrighty, let's code this. So first we're going to need a result variable so we can return at the end, and that's going to be equal to an empty array, because as you can see here, our results are actually inside of an array in the example that was given to us. And this is that array. Then below it, we're going to define our backtracking function. And this is basically going to create that tree that we had. And it's going to have a bunch of variables that we're going to give it as inputs. The first thing is going to be open count, just like we saw, and then close count. And obviously n that was given to us in the question, and also a string, so current string. Why do we have this? Well, you see, let's first of all enter this function. As we saw in the slides, we had open count, we had close count, and we also had n, and we had an empty string. So this current string is going to represent that. Here we said if open count is smaller than n, we can actually add an open parenthesis. So let's do that. We're going to call our function again, and we're going to add another open parenthesis. So we're going to say backtrack open count plus 1, because we just added 1. And then close count, and we're going to add our parenthesis here, like so, as you can see. And because we're adding an open parenthesis to our current string, we got to increment our open count. So this is going to add an open parenthesis, and then below it, we're going to say if close count is less than open count, just like we saw in the slides, do the following. This time, we're gonna add a close parenthesis. So let's do that. We're gonna say backtrack. This time, open count is gonna stay the same thing. A close count is gonna get incremented by 1 and is gonna stay the same. And our current string is gonna change because we're gonna add a closed parenthesis to it, like so. And this is everything, but we still have to return our answers. And as you remember in the slides, we had an extra line and we said if open count is equal to n and close count is also equal to n, do the following. Here we're gonna add our answer to our result array. So we're gonna say result dot push of current string, and then at the end we're gonna return. And this is it. We're saying after we actually have 3 open parentheses and close parentheses, that means our string is done. So let's add it to our result and return. And this is our backtracking function, but as you can see, we're not calling it anywhere, so we gotta call it. So we have to call it here, backtrack. So we gotta give it open count, close count, n in current string. In the beginning, we have no open parentheses, so this is gonna be 0. We have no close parentheses, so this is gonna be 0 as well. Our n was given to us, so we're just gonna pass it down because our n was given to us here. And then for our current string, we're gonna start with an empty string just like we saw in the slides. And this is it. And at the end, when this is done and our result variable is actually filled with answers, we're gonna return our result. Now let's run it and see if we're gonna pass our tests. Moment of truth. Yep, as you can see, both of them are passed. Now let's submit it and see if we're gonna actually pass everything. Let's see. Yep, and we're beating 94% of all of the other submissions. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.